Hi there, and welcome back. Let us look at this example over here. It is a statistical analysis related problem. We are told that operations manager of a manufacturer of a television remote control wants to determine which batteries will last the longest in his product. He took a random sample of his remote control and tested two brands of batteries. Here are the summaries given. We are told that N1, being the sample size for the first sample, was 4, the sample mean x1 was 107.5, and the sample standard deviation for S1 was 4.21. For brand 2, we are told that sample size N2 is equals to 4. Sample mean x2 is 116.75. Sample standard deviation for brand 2 is 16.61. The first question is, can the company infer that brand 1 will last longer on average than brand 2 through all calculations? And B says, estimate with a 95% level of confidence the difference between the two means. Okay, let us go through this problem step by step. To answer this, we need to perform what we call hypothesis testing. We start by using the F-test to check if the variance of the two samples are equal. Our null hypothesis is that the variances will be equal. The alternative hypothesis is that the variances are not equal. We can now therefore calculate the F value using the formula, the standard deviation for brand 1 and that of brand 2 both squared, and it should give us 0.064. Next, we need to find the critical F value. In this case, we use the alpha level of 0.05. Using the F distribution function on Excel, we find that F value is 9.28. Now, to conclude, we can say that since the calculated F value is 0.64, and it's less than that of the critical F value that we got from Excel, we failed to reject the null hypothesis. This means that there is no evidence suggesting that these variances differ between the two brands. Now, this means we can apply the t-test. Our null hypothesis is that the means of the two brands are equal. The alternative hypothesis is that the means of the two are not equal. We assume a significance level alpha of 0.5, which corresponds to a 95% confidence level. The test of the statistical analysis formula can be calculated using this formula here, and it should give us minus 1.05 if we substitute brand 1 and brand 2 means, and also standard deviation and the sample size. For the critical t-value, we use the t-distribution function with a degree of freedom n minus 1, which is the sample size minus 1. In this case, the degree of freedom will amount to 3. If we use Excel, we should get 3.18 for the t-critical value. To find the p-value, we can calculate it and assume that it's 2 times that of the value of alpha. Hence, the p-value amounted to 0.1. And using the t-distribution function, we can find the critical p-value. If you punch everything on Excel, it should give you 0.81. We can now therefore say, based on the results, since the calculated t-value, it's minus 1.05 and it's less than that of the t-critical value of 3.18. And the p-value of 0.1 is higher than the significance level of 0.05. We therefore fail to reject the null hypothesis. Therefore, we do not have enough evidence to suggest that brand 1 will last longer than brand 2 on average. Moving on to the second question, we are asked to estimate the difference between the two means with a 95% level of confidence. Now, the formula of estimating the difference between the two means is provided here. And if we plug these values that we just went over, this includes the mean of both samples, the standard deviation of both samples, and the sample size of both samples. We should get an answer. Therefore, our confidence level is minus 3.5, and 17.98. Conclusion, we cannot infer that brand 1 will last longer than brand 2 on average based on the statistical analysis performed. Also, with a 95% level of confidence, we estimate that the difference between the two means lies between minus 3.5.99 and 17.98.